Yesterday I tried the first ML coding problem, which is mostly just the normal coding, but with some LLM related twist. So I didn't do that well. I didn't do well at all. It was one of the worst cases of me streaming so far. So let's do it again today. But let's now, I will try to do different approaches because as you can see, this problem is not the same as usually in coding where you have to understand it. It's actually quite explicit. And in this scenario, you have to adapt. So I will have to adapt to that. And I will try to figure out how to adapt. Again, I haven't solved this problem before. I'm seeing it pretty much for the first time, and it was created by Claude. So today we are doing stream processing with stop sequences. Streaming response system for LLM-powered search engine. The model outputs text in chunks, and you need to truncate the output when a stop sequence is encountered. The challenge is that stop sequences may span across chunk boundaries. Okay. Given a complete string and a list of stop sequences, return the substring before the first occurrence of any stop sequence. Given a complete string and list of subsequences, return the substring before the first occurrence of any stop sequence. Okay, so basically when the stop sequence occurs, we need to stop at this point of time. I see. So part A, part B, iter is in iterables of string chunks that cannot be fully stored in memory. Return an iterable of chunks representing content before the first stop sequence. Chunks should be yielded as soon as it's safe to do so. Once you're certain they don't contain the start of a stop sequence. What optimizations? Very long stop sequences, large number of stop sequences, minimizing output latency. Okay, so I think I have an idea. So in the first part, we actually are already given given the signature. Let's now discuss some tests, right? So let's say the text is A, B, C, D, E. And let's say the stop sequences are A and C. Then we basically return an empty string because A is already should be a stop sequence. Okay, let's now say that instead of that, we have CD. So then we are returning AB. And what if we have CF? Then we don't have such a stop sequence. Okay, so this all looks good. There are obviously a few possible ways to solve it. So let's talk about solutions. Solutions. One of those would be to just iterate over all characters, all starting characters in the string, and then use function comparison. So compare of position in text and stop sequence. So then it either returns true or false. So it basically returns Boolean value, and we can, if we ever return any stop sequence, we know the position when we return it, so we return everything before this position. So it will be O of, let's say there are n chairs in text. Oops. And let's say there is m stop sequences. So for each of the characters, we can traverse up to n more characters n times. So it will be n squared m times m one time with no additional space of one space. So this is obviously problematic. How can we improve that? One of the ways is to use try. So we can put all our stop sequences in the try. Let's say that k length of the longest stop sequences. So then try will be basically, we will be iterating over try when we are trying to check whether some stop sequence exists or not at a specific place. So then it will be n, we will still be checking it for each of our characters, but then it will be multiplied by k, so nk, because yeah, for each of the characters we'll just need to traverse at most k elements. And basically here we also have like a minimum of n and k. So it's the minimum of n squared and k. I think this is the solution that we should be implementing. So let's try and implement it right now. So first of all, let's also create a class called try. And this. So self next will be default dict, and I think we also need to import that. So from collections import default dict, and then self end equals false by default. Okay, so then root will be try, then node will be equal to root, and for sequence in stop sequences, node will be equal to root, for character in sequence, let's call it letter because I think char is reserved keyword. So for letter in sequence, we have node next letter equals try, oh no, it will be node equal node next of letter because we are using default dict, so we don't need to do that. And once we have finished, node and equals true. Okay, so here we are. That's our try. We have created it from stop sequences. Now we need to iterate our text. So for I in range let's define a separate function. Traverse try from position to, let's call it I, and that's it. We also already have our try. So this I will be pointing in the specific position in text. So while I is smaller than the length of text, we do if, okay, we also have node equals root. So if text at ith position not in node next, return false. Else we do node equals node next of text of I. Actually, let's do this. It becomes less readable. So letter will be text of I. If letter, then node next letter. And okay, this is an integer and we will be returning boolean. Has stop sequence. Let's also call this position, just for clarity of what we are trying to do here. Position plus equals 1, and if node and return true. And then we are out of here. We need to return false. So if we iterate it over the whole stop sequence, the try might not be exhausted, but our text sequence is exhausted. We haven't found the end of this, so we now return false here. Okay, so now for I in range length text, if has stop sequence at I, return, so what did we return? Return text up to I, non-inclusive. I think that's the correct thing to do. Okay. So else return text. Yep. So we haven't, if we haven't found such a sequence and starting at any step in the try, we can just return text. And I think that finishes the implementation of the first part, of the part A. Okay, I need to also run this. All test passed. Great. Great, so we have passed all the tests. We have implemented this try correctly. Now we are doing streaming chunks. So we now need to return, we have an iterable, and we need to return an iterator. Okay, so we already have signature. Let's now discuss some tests again. So tests. First of all, it can be the same thing as it was before, right? So nothing new here, but it now can become more complex. So let's also try to do this more complex stuff. So A, B, C, and then D, E. And let's say that stop sequences are C, D. So then we are just returning A, B. Okay, yeah, I was thinking about how should I be approaching this. So we also don't just have this, we have this, but let's now also say something like B, C, D, E, or D, E, F, C, D, E. Then we'll again be returning A, B. Actually, let's also do A, B, C, D, E, F, and C, D, E. Yeah, and then we will need to return A, B. So how would this work, right? What can be the solution? So instead of text, we now have a sequence of chunks. We will be processing those chunks in sequence. So we will have two pointers, I think, right? So I will be pointing to chunk, J plays in the chunk. So then we will be iterating over chunks. So yeah, in our function, in our, how do we call it? Truncate and stop has stop sequence. Has stop sequence will be now of I and J. It will be iterating over chunks. And yeah, another position, like our initial position will also be I and J. And once the position, the external position, this position, I, gets out of the chunk, we yield this chunk. And then we transition to the next one. So there will be this additional managing of the chunks themselves. So essentially it will still be, let's say we have n chunks, m chars per chunk, k max length of the stop sequence, then it will be of nmk runtime. Oh, and I forgot to mention space complexity, right? So space complexity here for try will be essentially, how do we define it? M stop sequences times k, right? So it will be up to mk space. And here the space will be still, we need a new value. Let's say p stop sequences. Let's actually change this. So for consistency, how it was before, m stop sequences, p chars per chunk. So m and pk and mk space. And this will be the most efficient algorithm that we can do here, I think. So now I'm ready to implement it. So let's start implementing things. So we have chunks, stop sequences. So now truncate stream at stop, truncated stop. Yeah, fortunately we can still create the try just in the same way. So I will start by copying all of that. Correct implementation. Okay, for sequence and stop sequences, yes, I'm doing that. That's correct. Now this needs to change chunk position. Okay, so chunk and position, and now node root, and while key. While chunk is smaller than chunks, so we take that's called chunk ID, just to be chunk I, so that we don't mix it up with something else. So while chunk ith is smaller the length of chunks, we now start iterating from this specific position. So we are guaranteed that this position exists. We will need to track this both outside and inside. So now letter will be chunks, chunk I at position. Node next equals letter and position plus or equals 1. Okay. So now here we need to check if position equals length. I will also, I hope I can assume that all chunks are non-empty. Assumes all chunks are non-empty. If some of them are empty, I will just need to do an additional step of dropping an empty chunk when it comes to the stream. So if position equals length of chunks chunk, actually let me just do that. No, I will not be doing that. I wanted to just choose it, but I'm trying to figure out what is a nicer way to implement this. Okay, so if position is equal to length of this specific chunk, it means that we need to iterate and increase the number of chunks. So chunk I will be plus equal 1, and position in this chunk will be equal to 0. If node end, we return false, and if we have iterated over all the chunks, we just return false. Okay, that's good. So now we need to do for chunk I in range length of chunks. If a stop sequence of for position in range length of chunks chunk I, if we have a stop sequence here, we need to return okay, so if we have position, so we yield chunk I up to position, and here we are obviously passing chunk I and position. Okay, so we have iterated now over the whole chunk. Once we have iterated over the whole chunk, we just yield it. Yield chunks chunk I. I'm not getting what's wrong here. Oh, that was funny. And here we also need to return. So we basically stop doing anything. Yep. Okay, task bar B. I also need to call this. Task bar B. Oh, I did something strange, right? Letter equals chunks chunk I position. Yep, part B all test passed. This was almost perfect. Very close to perfect. Yeah, I should probably also test my solutions first before submitting, but I don't have much time today. I was trying to be quick. And that's it. Let me see what are the questions that I'm getting. So, question: which is the best job to enter in cloud skills like cloud support, etc., and then to switch in cloud engineer, because entering is the hardest part? Well, I don't have any especially good advice for freshers because I'm not in the same position, and you probably have your own struggles that I'm not aware of. But when I was a fresher, I also had like a lot of problems trying to get my first job. So what I did, I started participating in a lot of hackathons to be recognized, and like every country, every big city, even online, you can find a lot of hackathons. Hackathons, competitions, those are good ways to improve your skills and also to be recognized in the industry and land your first opportunity. That is something that I still recommend. And at that, let me pause and see you all tomorrow.